multiple vectors. So there's one of the confusing questions on the quiz, honestly. So you want to do the multiple vectors one in the textbook because that's going to help you out. You can also look at it in the lab, the 2.1 application. But in addition, you can also look at it here to make sure that you're getting the idea. So again, I always do a similar question, not the exact one, because this is on the quiz. And when you get this, you could get any number of 4 different varieties of this. So don't assume when you take attempt 1 and you get your answer and like, woo, I got this one right. And then in attempt 2, you just write down that answer. You're going to get it all wrong because you're going to get one of the other 3 varieties of this question. So in this one, I have G to C. And it tells us somewhere, so really pay attention. It tells you somewhere how big the blocks are. So how many blocks do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So on your quiz, it could give you a different one each time. So just pay attention. So we have 12 blocks, but we know that there's 20 meters per block. So we know we're first going to start with vector GC, and that is going 240 meters west. Magnitude, units, direction. And then it says, if you walk from C to A, shortcuts allowed, what is the vector? So C to A, that would be this vector here from C to A. What did it mean by shortcuts allowed? It meant that you don't have to stay on the path. You just want the displacement of C to A. And it may use some other terminology there. Just when it's talking about it, it is talking about the vector quantity. So you want that displacement quantity. So there that is in blue. And what is that vector? Okay, so what can we figure out from this? Draw in your x and y's and your thetas. Okay, so there's your vector in the x, your vector in the y, to get your total vector with your theta. Okay, now what do I know? Break it down. What is my velocity in the x, or my vector in the x, because it's not velocity, it's just a vector. 1, 2, 3, 4, 5, 6. So it is 6 times 20, or 120. What is my velocity vector in the y? 1, 2. Okay, and it's 2 blocks down. 2 times 20, or 40. So how can I figure out my resultant? 40 squared plus 120 squared. Take the square root of all that. That would give me my magnitude, but I need my angle too. What could I use for my angle? When I'm doing angles on these, I try to use the numbers that they gave me and not the one I calculate. That just reduces error. So I have the opposite and the adjacent. So that's going to mean I'm going to do a TOA. Tangent of theta is equal to 40 over 120. I got to get rid of the tangent to see the on that. So tangent -1 times the quantity, 40 over 20, is going to give me my answer for the vector from C to A. That would be 126 southwest. So in this case, it did not need my angle. Okay. Compare the distance and displacement from G to C to A. So compare the distance and displacement. So we had the G to C, okay, is 240 west, and your C to A is 126. So the path is going to be 366. That's the path because I just added the 2 vectors directly. But the displacement of that is when we have those multiple vectors in there. And so we need to get it from G to A. When you're going all the way G to C to A, you would have to do that same thing that we did before. Find the X component and find the Y component and the X component. So that's how you do it. But when you are doing the distance from G to C to A, you're doing that pathway right there. So if they just wanted the full vector from G to A, yep, you would be finding it that way. Yep, and if you have to, it's hard to see, you can zoom your screen when you're on Canvas so that you can count those little blocks. Yeah, just go slowly, make sure you don't count them incorrectly.